all viewers of this channel. So in this video, I'm going to discuss the illustrations of quadratic equations. So in this lesson, we're going to illustrate quadratic equation. At the same time, I'm going to teach you how to write quadratic equation into its standard form for us to be easily obtain the values of a, b, and c, in which that concept is we're going to use on the following lessons. So before we proceed with the process, let us first define quadratic equation. So quadratic equation, it is an equation in one variable with the highest degree of 2 that can be written in standard form ax squared plus bx plus c equal to 0, where a, b, and c are real numbers and a must not be equal to 0. Quadratic equation is also called as the second degree equation, in which the highest degree or the highest exponent must be equal to 2. So I have here examples, and what we're going to do is to identify whether the equation is considered as quadratic equation or not. So I have here 6 equations. The first one is 2x squared plus x minus 3 equal to 0. Equation number 2 is x plus 5 equal to 9. Equation number 3 is 4x squared plus 3 equal to 0. Equation number 4 is 5x minus 3 equal to 2x. Equation number 5 is x squared minus 5x equal to 4. And equation number 6 is 2x cubed plus x squared minus 3x plus 2 equal to 0. Now let us observe the first given, which is 2x squared plus x minus 3 equal to 0. So going back with the definition of quadratic equation, for us to consider an equation, a quadratic equation, we need to have the highest exponent of 2. As we can see here, we have two variables, which is x squared and x. So here we have the highest exponent of 2. So therefore, we can consider this equation as quadratic. Equation number 2 given is x plus 5 equal to 9. So as we can see here, we have only one variable, which is x. So if we have this type of variable, it is understood that the exponent of this is equal to 1. So as we can see, the highest exponent of this particular equation is only 1. So therefore, we cannot consider equation number 2 as quadratic equation. Okay, next is the third equation given by 4x squared plus 3 equal to 0. So as we can see here, we have only one variable with the exponent of 2. So therefore, we can say that this particular equation has the highest exponent of 2. So therefore, we can consider 4x plus 3 equal to 0 as quadratic equation. Okay, number 4. Equation number 4 is given 5x minus 3 equal to 2x. So we have two variables here from in the left and in the right part of the equation. We have the variable x. So same with equation number 2, it has the exponent of 1. Same with the other side. So therefore, the highest exponent of this equation is 1. So we cannot consider this equation as quadratic since the highest exponent is only 1. Equation number 5 is x squared minus 5x equal to 4. So let us observe. We have here two variables, x squared and x. So you have here the exponent of 2, and here is exponent is 1. And then we have the constant term at the right side of the equation. So now, let us observe with the highest degree. So the highest degree or the highest exponent of this equation is 2. So therefore, we can consider equation number 5 as a quadratic equation since the highest degree is 2. Finally, we have equation number 6 given by 2x cubed plus x squared minus 3x plus 2 equal to 0. So as we can see here, by observing, we have three variables. We have x cubed, x squared, and x. So what can you observe? Our highest exponent in this equation is 3. Going back with the definition of quadratic equation, it is a second degree equation in which the highest degree or the highest exponent is only 2. Since this equation has the highest degree of 3, we cannot consider this equation as quadratic. So therefore, equation number 6 is not a quadratic equation. So the only equations that we can consider as quadratic equation here are equation 1, equation 3, and equation 5 because their highest degree or their highest exponent is equal to 2. So let us now apply our knowledge in this equation in writing the equation in standard form. Going back, the standard form of this equation, the quadratic equation, is given by ax squared plus bx plus c equal to 0. So this equation has three terms. Ax squared, which is called the quadratic term, that has a numerical coefficient that is equal to a, and the variable which is x squared. The second one is bx. So in bx, b is the numerical coefficient while x is the variable and bx is our linear term. The third term is the c or the constant term. Those three terms are the terms in the standard form of quadratic equation ax squared plus bx plus c equal to 0. Let us now proceed with the examples. I have here example number 1 given by 4x squared plus 2x minus 5 equal to 0. So our objective here is to write the equation into its standard form. And then let's identify the quadratic, the linear, and the constant term. After that, we're going to, from the terms, we can obtain the values of a, b, and c. As you can see here, 4x squared plus 2x minus 5 equal to 0 is already written in its standard form, which is ax squared plus bx plus c equal to 0. So by that, we can already identify the quadratic term, the linear term, and the constant term. 4x squared is the quadratic term here. 2x is the linear term. And then negative 5 is the constant term. So since we already identified the terms, we can also obtain the values of a, b, and c. Respectively, the values of a, b, and c are 4, 2, and negative 5. The value of a, which is positive 4, came from the quadratic term. A is the coefficient of x squared, so that is positive 4. B is equal to 2 since the numerical coefficient of the linear term x is 2, positive 2. So the value of B is 2. And finally, the value of C is equal to negative 5 since the value of our constant term is negative 5. So you just copy negative 5 from the given. So that will be our C equal to negative 5. Let's have a similar example. Here in example number 2, we are given 3x squared minus x plus 8 equal to 0. So again, this example is already written in standard form. So we can already identify the quadratic term, linear term, and the constant term. That is 3x squared, which is our quadratic term, And then negative x is our linear term, and positive 8 is the constant term. So from that, we could obtain the values of a, b, and c. So the value of a is positive 3, since the numerical coefficient of the quadratic term is positive 3. The value of b is negative 1, since the numerical coefficient of the linear term is negative 1. If the numerical coefficient is not written here, it is understood that the numerical coefficient is 1. And since the sign of this term is negative, that is understood that the value of b is equal to negative 1. And finally, the value of c is 8, since the value of the constant term is positive 8. Okay, so let us now proceed with the third example. And the third example, we are given 4x quantity, x plus 3 quantity equal to 1. Example number 3 is also a quadratic equation. However, this equation is not written in standard form. So all we have to do is to write it into its standard form using recall of the property which is called the distributive property, in which we're going to multiply 4x to each term of this binomial, which is x plus 3, or the term inside the, or the expression inside the parentheses. So we're going to multiply 4x to x first, followed by 4x to positive 3. So by multiplying 4x to x plus 3, we could obtain 4x squared plus 12x equal to 1. All we have to do is to copy the expression at the right side of the equation. So we multiply 4x to x, that's why we get 4x squared, followed by 4x times positive 3. So 4x times positive 3 is positive 12x equal to 1. The next thing that we need to do is to make this right side of the equation 0. So to do this, since we have positive 1, we're going to use an equality property of equality of subtraction, since this is positive 1. So we're going to make this 0, so we're going to subtract 1, so that 1 minus 1 is equal to 0. Since we subtract 1 at the right side, since this is an equality, we need to subtract also 1 at the left side of the equation. So we could obtain this equation, 4x squared plus 12x minus 1 equal to 1 minus 1. So 1 minus 1 now is 0. Since we subtract 1 at the right side, we need to subtract 1 also at the left side. So we get 4x squared plus 12x minus 1. You just copy the terms, equal to 1 minus 1 equal to 0. So as we can see here now, we have 4x squared plus 12x minus 1 equal to 0, which is now written in standard form. So therefore, we can now identify the quadratic term as 4x squared, the linear term as 12x, and then the constant term as negative 1. So by that, we could get now the values of a, b, and c. Since the numerical coefficient of the quadratic term is positive 4, so therefore the value of a is positive 4. Since the numerical coefficient of the linear term is 12, so we could get now the value of b, which is equal to positive 12. And then the value of our constant term here is negative 1. So therefore, the value of c here is equal to negative 1. That's it. Okay, let's try a similar example here. For example number 4. In example number 4, we are given 2x quantity 3x minus 1 equal to negative 6. So, same property, we're just going to use the distributive property by multiplying 2x to each term inside the parentheses. So that is 2x times 3x followed by 2x times negative 1 equal to, you just copy the constant term here, negative 6. So by that, we could get 6x squared minus 2x. That is by multiplying 2x by 3x. So that is 2 times 3, which is 6, and x times x, which is x squared. After that, we multiply 2x naman to negative 1. So 2x times negative 1 is negative 2x. Equal to, you copy the term at the right side of the equation, which is negative 6. Again, the next thing to do is to make the right side of this equation 0. So how are we going to make negative 6 to be 0? So all we have to do is to add 6. So if we add 6 to negative 6, applying the rules of combining integers, we get 0. So since we're going to add 6 here at the right side, we're going to add 6 also at the left side. So we could have 6x squared minus 2x plus 6 equal to negative 6 plus 6. So the right side now becomes 0 since negative 6 plus 6 is equal to 0. So you just copy the left side. We have 6x squared minus 2x plus 6 equal to 0. So since this equation is now written in standard form, we can now identify the terms. So 6x squared is the quadratic term. Negative 2x is the linear term. Positive 6 is the constant term. After that, we obtain the values of a, b, and c. So a is equal to 6. Since the numerical coefficient of the quadratic term is positive 6. The value of b is negative 2. Since the numerical coefficient of the linear term x is negative 2. And then the value of c is positive 6 since the constant term is equal to positive 6. Okay? Okay, so let us now try different situation for example number 5. So example number 5, we are given x minus 3 multiplied to x plus 5 equal to 2. As we can see here, we have two binomials. So what we're going to use here is a method that we call the FOIL method, which stands for first, outer, inner, and the last terms. Using this, let's start with the first terms by multiplying the first terms of the two binomials, which is x and x. So multiplying x to x, we get x squared. So those are the first terms of the two binomials. Followed by the outer terms given by x and positive 5. So all you have to do is to multiply them. X times positive 5, that is equal to positive 5x. That is for the outer terms. Next, we have the inner terms of the two binomials, which is negative 3 and positive x. So by multiplying negative 3 to x, we get negative 3x. So those are the inner terms. Finally, we have the last terms of the two binomials. We have negative 3 and positive 5. So multiplying negative 3 and positive 5, we get negative 15. After that, after applying the FOIL method, all you have to do is to write the expression at the left side of the equation as x squared plus 5x minus 3x minus 15 equal to 2. So as we can see here, we have two like terms, which is positive 5x and negative 3x. So all you have to do is to apply the rules in combining integers, in which we're just going to combine their numerical coefficient, which is positive 5 and negative 3. So combining them, we have 5x minus 3x. All you have to do is to copy the quadratic term, x squared, and then you combine 5x and 3x. 5x minus 3x is positive 2x. That is just 5 minus 3, and then you copy the common variable. After that, you copy the third term, minus 15 equal to 2. Just like we did from the previous examples, we need to make this positive 2 equal to 0. So to do that, we need to use the subtraction property of equality by subtracting 2 here, so that this right side will become 0. Since this is an equality, if we subtract 2 at the left side, we need to subtract 2 also at the right side. So obtaining x squared plus 2x minus 15 minus 2 equal to 2 minus 2. So we have negative 2 or minus 2 in the both side of the equation. And then you can observe also that we have two constant terms, which is negative 15 and negative 2. So all you have to do is to combine them using the rules of combining integers. So you copy first the quadratic term, x squared, and the linear term, positive 2x. And then you combine negative 15 and negative 2. So that is negative 15 minus 2. Since they have the same sign, all you have to do is to add the numbers 15 plus 2 and then copy their common signs. So 15 plus 2 is 17. Their common sign is negative. So we copy negative 17 or minus 17 equal to, look at the right side of the equation, 2 minus 2 is now equal to 0. So therefore, x squared plus 2x minus 17 equal to 0 is now written in its standard form. After that, we can now identify the terms, the quadratic term, the linear term, and the constant term. We are now ready to get the values of a, b, and c. So a is equal to 1 here, since the numerical coefficient of the quadratic term is understood as positive 1. So a is equal to 1. B is equal to 2, since the numerical coefficient of the linear term is 2 or positive 2. So B is equal to 2. And C is equal to negative 17, since the constant term is negative 17. So that's it. So let's have the similar example for example number 6. In example number 6, we are given quantity 2x plus 1 multiplied to quantity x minus 3 equal to negative 1. The same manner, we're just going to use the FOIL method by multiplying their first, outer, inner, and last terms. So proceed. Start with the first terms, multiplying 2x to x. So 2x times x, we get 2x squared. After that, we multiply their outer terms, that is 2x times negative 3. So multiplying 2x to negative 3, we get negative 6x. So those are the outer terms. Followed by the inner terms, multiplying positive 1 and positive x. So multiplying 1 times x, we get positive x. And finally, we multiply their last terms. So we multiply now positive 1 and negative 3. So positive 1 times negative 3, we get negative 3. After applying the FOIL method, all we have to do is to write the expression of the left side of the equation. So that is 2x squared minus 6x plus x minus 3 equal to, copy the constant term minus negative 1 at the right side of the equation. Again, we can observe that we have two linear terms, which is negative 6x plus x. All we have to do is to apply the rules in combining integers. So since we have here negative 6 and positive 1 here, so by applying, we have unlike sign, so we have to subtract. So 6 minus 1 is 5. And then we copy the sign of the larger number, which is negative. So we get negative 5x. So now we copy the quadratic term 2x squared, and then the answer by combining negative 6x plus x, that is negative 5x. copy the third term, minus 3 equal to negative 1. The next thing to do is to make this negative 1 0. So to do that, we need to add 1. So if we add 1 at the right side, we need to add 1 also at the left side. By that, we have 2x squared minus 5x minus 3 plus 1 equal to negative 1 plus 1. So this expression at the right side will become now 0. And then on the left side, we could observe that we have two constant terms. So we need to combine them using the rules in combining integers. So the first thing is you copy the quadratic term and then the linear term. And then you combine the two, negative 3 plus 1. Since we have a like sign, we need to subtract 3 minus 1, which is 2. And then you copy the sign of the larger number, which is negative. So the answer is negative 2. So that we have 2x squared minus 5x minus 2 equal to, you simplify this one, so negative 1 plus 1 is now equal to 0. So our quadratic term here is 2x squared minus 5x minus 2 equal to 0. So by that, we have the quadratic term, the linear term, and the constant term. We are now ready to get the values of a, b, and c. The value of a is equal to positive 2 since the numerical coefficient of the quadratic term, or x squared, is 2. The value of b is negative 5 since the numerical coefficient of the linear term x is negative 5. The value of c is equal to negative 2 since the constant term is equal to negative 2. That's it. I think this time we are ready to have some exercises. Let's start with the fast mind exercise. All you have to do is to apply the knowledge that we have learned from the discussion. So the first exercise is that what we call the fast mind exercise. So let us read the direction. According to the direction, which of the following are considered as quadratic equations? So you're going to identify which of the 6 equations here are quadratic equations. I'm giving you 30 seconds to do that. So you now get your pen and paper and then write your answer. Which of these 6 equations are considered as quadratic? Your time starts now. Okay, time is up. So before I reveal the answers, I want you to write later after the answers. Write your score on the comment section of this video. Okay, which of the following are considered as quadratic equations? So we have equation 6, x squared minus 5 equal to 0. Equation 3, 6x squared minus x plus 3 equal to 0. And equation 4, x squared minus 10x equal to 3. So we have 3 equations here that are considered as quadratic equation. Kindly write your scores on the comment section so that I know if you have learned something from the discussion. Let us know. Okay, let us now proceed with the next exercise, which is called the fast hand exercise. So this exercise is, you're going to answer this exercise for 10 minutes. I think that's enough to finish the activity. So what you're going to do here, so let us read the direction. Write the following quadratic equations in standard form and identify the values of A, B, and C. So all you have to do is to write these given equations into its standard form. You don't need to identify the terms. All you have to do is to get the values of A, B, and C. So get your pen and papers now to answer this exercise, and after checking this exercise later, I want you to put your scores on the comment section of this video so that I know if you have learned something from the discussion a while ago. All you have to do is to apply what you have learned from the examples number 1 to 6 in this exercise. Are you ready? Okay, your time again. Your time starts now. 20 seconds. Get ready. Time is up. Okay, let us check now your answers. Make sure that you write the scores on the comment part of this video. Okay, let us check your answers on these exercises. Okay, we could have 2 points for this and 1 point for each value. So each letter must have 5 points each. So 2 points for the equation written in standard form, 1 point for the value of A, 1 point for the value of B, and 1 point for the value of C. So total we have 25 points. Kindly check your work and write your scores on the comment section of this video. Last 30 seconds of checking. Okay, that's it. Okay, again, write your scores on the comment section of this video. So before we say our goodbye for this video, I have here your assignment. So the same with your task a while ago, you're just going to write the following quadratic equations in standard form and identify the values of A, B, and C. Kindly copy your assignment, and then we're going to check these at the start of the next video. So I'll give you 1 minute to copy the home task. Okay, that's it. Thank you for listening on the discussion. See you on my next video. Bye bye.